Hello there, welcome again to this video. For this video, what I would like to share or to discuss today are the terms related to circle. Remember the words we will encounter later. We have the chord, we have arc, inscribed angle, and central angle. Circle is very interesting figure, geometrical figure, because you can see it around. When you look at the tire of your car, when you eat pizza, and also when you look at the coins in your pocket, they all describe the shape of a circle. To give more meaning of this shape, let me give to you a situation. Okay, so I have a situation. Imagine, okay, let's try to imagine that you are sitting on a bench at the center of a perfectly round garden. So let's try to draw this one to better visualize. So let's say this is the perfect round garden, and you are sitting at the center of this perfectly round garden. So let's say at this point you are let's say this is Maria. So let's say this is point M, which stands for the name Maria. Then there are three people in your family standing at different places around the garden. Okay, so they're the members of your family is standing around the circle. So one to your right will be here. So let's say this is point for the S. So this is point E. Another to your left. So for your left, let's say this is your west part. So let's just W. And the last one is in front of you. So this is the front of you, will be here. So let's say F denotes for the person in front of you. When a line is drawn from you to the person in front of you, so let's try to do this one, straight line. And another line from you to the person on your left. So on my left, there will be another line. You form a central angle. So where is the central angle? So this one. So from the center to my person, to my point in the front, and from the center to the person in my left, I form a central angle, which is this one, which is a 90 degrees central angle, which can be denoted by angle FMW, or let's say we can interchange this one WMF, as long as the vertex must be in the center. Okay, that is very amazing, right? Now let's continue. When a line is drawn from the person to your left, the person in the front of you, so the person in my left I have here, to the person in front of me or of you, so from point W to point F, this is the line. Let's connect these points. The straight line is what we call the chord. So this line from point W to point F, we call this line as a chord rather. So therefore, a chord is a straight line from one point of the circle to the other. So from one point here to this one, we call this one as our chord. So we can write this one in the notation line or the segment FW or the segment WF, which stands for this line. And take note for the notation that we are using. Right? So we have this one, this is the chord, this is the central angle, okay. So next, arc is a curved shape, which is the distance around the surface of the circular garden. So arc here is the distance around the surface. So again, arc is a curved shape. So this one, it is a curved shape, which is the distance around the surface of the circular garden. So let's say FW is an arc because it is a curved shape and it refers to the distance around some parts of the circle from point F and to point W. So this is the arc. So instead of straight line, we use this symbol, this curve, or let's say this is WF, arc WF. So we call this one as our arc. Okay. So if you observe, we have this one. This is a small arc. Another example is, or one interesting fact here is about arc is we have this one, the major arc is the biggest arc here from point F, E, and W. So we can notate this one as arc F, E, W, or else we can say arc W, E, F. We call this one as our arc, particularly the major arc. And we can also say that arc FW or arc WF is the minor arc. Obviously, that is the minor arc because that is small curve from point F to W, as you can see in the diagram. But by definition, to define this one, the major arc is the arc which measures greater than 180 degrees, right? But before that one, we can notice here that we have the diameter of the circle from point W to the point E, right? Which measures, this is 180 degrees. So this diameter divides the circle into equal parts. If we add 180 degrees plus the other side of the circle, which is also 180 degrees, we'll get a total of 360 degrees, right? So therefore, we can say that the major arc is an arc measuring greater than 180 degrees. So as you can see in the diagram or in the picture, from point W to the point F, that is greater than 180 degrees. On the other hand, minor arc is an arc which measures less than less than 180 degrees. So from point F to point W, this arc is measuring 90 degrees, which is less than 180 degrees. Therefore, we can say arc FW is a minor arc, right? Okay? So, now, if you draw two lines from the person to your left, going to the person on your right, here, and to the person in front of you, so this one. So I have this line already, from the person in my left to the person to my right, then from the person to my left to the person in front of me, or in front of you, this forms an inscribed angle. So we call this one again as our inscribed angle. So inscribed angle, by definition, whose vertex is on the circle and whose sides contain chords of the circle. Okay? So this one, so the vertex here is this one, the vertex of this angle obviously is this one. So we have the angle FWE, which is the vertex is on the circle, and we call this angle as our inscribed angle. So this will be our inscribed angle. Okay, and another also here that the legs of this angle contains the chord of the circle, which is chord FW or WF, and we have the chord WE. Take note that the diameter of the circle is the longest chord of the circle, right? So we can write this one as we can notate this one. We have the diameter segment WE or segment EW. This is our diameter. Okay, so we have also here the radius, which is 1/2 of the diameter from point M to point W. So from point M to point W, or we have also here point W to point M. We call this one as our radius, which is 1/2 of the diameter. Okay, so let's check again. Terms related to circle, we have the chord. So we found out that the chord is measuring, or we have the notation segment FW or segment WF. Then we have our arc. We have the major arc and the minor arc. And also, another interesting thing that we should not forget in this lesson is what we call the intercepted arc. Okay, by definition, intercepted arc is the arc that lies in the interior of an angle and has endpoints on the angle. So from the given here, we have lots of in the given circle we have lots of intercepted arc. One example of this is we have arc FW because it lies in the interior of an angle. We have the angle FMW, and this arc is what we call as our intercepted arc. Notice that arc W can be intercepted arc, our arc, or the minor arc itself. And we also have another one, intercepted arc here. If you notice in the drawing, we have arc FE because of this angle, the central angle FME. So arc FE is also our intercepted arc, right? So let's check. Let's try to evaluate or to answer this one if you really grasp the concept about our lesson today. So given the circle, we have the circle B and having a point on the circle DAC and the center at B. So just give to me one intercepted arc. Okay, so we have here one intercepted arc, which is arc AC, right? Because this arc is or lies in the interior of the angle, which is angle ABC, right? Then we have the chord. We have lots of chords here. We can say chord AC or chord DC as our longest chord. Let's say this is chord AC. Beware of the notation you are using. This is the chord. This is the chord, meaning this is straight line. So we better use straight line. And this arc is for arc AC, right? Then we have the central angle. The central angle is the angle whose vertex is in the center of the circle. We have obviously we have here just give to me a one central angle, which is equivalent to angle A, the center B, then C, right? Next, one inscribed angle. So again, the inscribed angle whose vertex lies on the on the circumference of the circle. So you have the vertex here, angle ACD, whose vertex is in the circle. So we call this one as angle ACD, right? Okay, next, let's find the one radius. So we have the radius here, we have the BC, radius BC. Next, one minor arc. So again, minor arc is an arc whose measure is less than 180 degrees. So we have the minor arc here. If you observe this one, if you analyze the circle, we have arc DA, minor arc AC, minor arc AD. Okay, we have only two minor arcs, but let us write only one, which is arc. Also, we can write arc AC. Okay, you observe we have arc AC answer number 1, because at the same time arc AC is an intercepted arc, right? Next, one major arc. Our major arc here, again, it should measure greater than 180 degrees. So we have arc ADC. So I have here arc ADC, right? Next, one diameter. Of course, we have one diameter here. So we have segment DC. It should be from the point here, and it should pass the center and connect to the other point in the circle. Next, a semicircle. So a semicircle, as we know, it is half of the circle. So if you notate this one, that is, we have arc DAC, which is a half circle. So arc DAC is a half circle or a semicircle. Okay, now for the last example, in number 10, if segment DB, so this one, so segment DB is obviously as our radius, right? Next, and segment BC is equivalent to 2x plus 48. So BC is this also one, the radius. Then find the measurement of the radius of circle B. So to find this one, to solve this problem, let me solve this problem in this separate sheet. So we have this one. Notice that the radius in the circle, or the radii in the circle, they all have the same measurement. So from this point to this point is the same as from this point to this point, or else we can say that segment DB is equivalent to segment BA and also equivalent to segment BC. So therefore, we know that DB is equivalent to, in the given problem, 5x minus 9, and we know that segment BC is equivalent to 2x plus 48. So to solve this one, we will use the fact that they are equal, right? So 5x minus 9 is equal to 2x plus 48, right? Then perform this one. So 5x minus 2x 48 plus 9, right? So to solve for x, we will subtract our left side, which is 3x, and sum up our right side, which is 57. Then multiply this one by 1/3. So we can cancel 3 in our left hand side, Therefore, x is equal to 19. Right? So 3 times 19, that is 57. So therefore, the radius is measuring 19 units. Okay? I hope you learn in this video.